Hey knowledgeable, welcome to today's session. So before I move ahead with this topic, I just want to put a disclaimer here that some of the images has been taken from the NCERT book. So you will find watermark printed too. However, I think that should not come in way of your understanding the topic. So today we would be talking about common factor, common multiple, prime factorization, HCF that is highest common factor, LCM that is lowest common multiplier, and we'll do some question and answer. So before moving ahead with this video, if you are not very much familiar with the concept of the factor and multiple, then you can go through the video which I have made earlier. So I will put the link in the card and also in the description. So coming to the common factor, what is common factor? Factors which are common are called common factors. So let's see with an example. The factors of 4 are 1, 2, and 4. The factors of 18 are 1, 2, 3, 6, 9, and 18. The numbers 1 and 2 are the factors of both 4 and 18. Hence, 1 and 2 will be called common factors. So we can see this 1 is common, 2 is common, and no other factors are common. Hence, we can tell 1 and 2 are the common factors of 4 and 18. So let's see another example of common factor. So find the common factor between 4, 12, and 36. So what are the factors of 4? That is 1, 2, 4. In the same way, factors of 12 are 1, 2, 3, 4, 6, and 12. And the factors of 16 are 1, 2, 4, 8, and 16. And if you see what is the common, so 1 is common in all the 3, 2 is common in all the 3, and 4 is common in all the 3. So we can tell that 1, 2, and 4 are the common factors of 4, 12, and 16. So coming to the common multiple, let's see what are common multiples. So multiples which are common are called common multiples. So for example, if we have to find the common multiples of 3, 5, and 6, then let's see what are the multiples of 3. So multiple of 3 are 3, 6, 9, 12, and so on. In the same way, multiple of 5 are 5, 10, 15, and so on. And multiple of 6 are 6, 12, 18, and so on. And when you try to find the common multiples of 3, 5, and 6, so you will get something like 30, 60, and some other number ahead. So all these numbers will be called common multiples of 3, 5, and 6. So now let's come to the prime factorization. So what is prime factorization? So if a number can be written as a product of prime factor, then it is called prime factorization. So if you see 36 can be written as 2 into 18, 3 into 12, 4 into 9, or 6 into 6. But this will not be called a prime factorization because the number here, if you see 18, is not a prime number. In the same way, 12 is also not a prime number. 4 and 9 is also not a prime number. And 6 and 6 is also not a prime number. So we can't call it as a prime factorization. So we'll have to break it down to the smaller number which are prime factor. So when this non-prime factor has been broken down, ultimately you will get a single prime factorization. So that is 2 into 2 into 3 into 3. And you will get the same in all the cases. So that you have to note that there will be only one prime factorization. So let's see how to do the prime factorization. So if you have to do the prime factorization of 36, then start dividing the number with the smallest prime number. If you are not able to divide with the smallest prime number, then go with the next one and so on. So if you see here 36, right, we started dividing with the smallest prime number, that is 2. We get the quotient as 18. Again, we try to divide with the smallest prime number. So we see that we are able to divide. So we will divide it with 2 and we get quotient as 9. Since we can't divide 9 with 2, so we'll go with the next prime number, that is 3. And by dividing 9 with 3, we'll get 3. So yes, 3 can be also divided with the 3. So we'll get 1. So here the prime factorization of 36 would be 36 can be written as 2 into 2 into 3 into 3. So this is the result of the prime factorization of 36. So same thing is written here in this slide. So let's see what is HCF, GCF, and GCD. So HCF full form is highest common factor, GCF full form is greatest common factor, and GCD is greatest common divisor. And all of these three are same. So we will just try to define one of those things, that is HCF. So the highest common factor of two or given number is the highest or greatest of their common factors. So let's try to see how to find the HCF for given numbers. So if we have to find the HCF of 20, 28 and 36, then what we'll do, we'll try to see the factors of 20, 28 and 36. So if you see the factor of 20 are 1, 2, 4, 5, 10 and 20. In the same way, the factor of 28 are 1, 2, 4, 7, 14 and 28. And the factor of 36 are 1, 2, 3, 4, 6, 9, 12, 18 and 36. So if you see the highest common factor between all these three numbers are 4. So any number which is greater than 4 is not common to them. So take 5, 10, 20, anything that is not common to them. So we can tell that the highest factor that is common is 4. So we can say HCF of 20, 28 and 36 is 4. So let's try to find the HCF with another method, that is by prime factorization method. So if we have to find the HCF of 20, 28 and 36, then what we'll do? So first we'll try to get the prime factorization of 20, 28 and 36. And we already know how to get the prime factorization of the number. And then what we'll try to do, we'll try to find the common factors there. So that is 2. And here again, another 2 is also common. And whatever is common, we'll try to take it once and multiply it. So that you will get 4. So here is a home task. Think about this one. If you don't do prime factorization, will you be able to find the HCF correctly? So now let's see what is LCM. So full form of LCM is lowest common multiple. So lowest common multiple of two or more given numbers is the lowest or the smallest or least of their common multiples. Let's try to see how to find the LCM. Is the method 1. So we have to find the LCM of 4 and 6. So multiple of 4 are 4, 8, 12, 16 and so on. And multiple of 6 are 6, 12, 18 and so on. So if you see the lowest common multiple of 4 and 6 is 12. Let's try to see how we can find the LCM by another method, that is by the prime factorization method. So we have to find the LCM for number 20, 28 and 36. First we'll have to do the prime factorization of number 20, 28 and 36. So we already know how it can be done. Then we'll try to see how we can find the LCM. So find all the prime factors. So what are the different prime factors here? That is 2, 3, 5 and 7 for a prime factor. So let's take 2 first. Find the number where it is occurring maximum times. So if you see, that is in 20 it is occurring 2 times, in 28 it is occurring 2 times, in 36 it is occurring 2 times. So we can take any of the number. Let's take number 36 where it is occurring maximum number of times. So count the numbers of times it is occurring in that number. So in this, for this number 2 is occurring 2 times. Multiply the factor that many times. So we'll multiply factor 2 2 times. So let's go to the another factor, that is 3. We'll do the similar thing. So where it is occurring maximum number of times, that is occurring in 36. And how many times it is occurring, that is 2 times. So we'll multiply factor 2 times. So for 5 we'll do the same thing where it is occurring maximum number of times, so that is in 20. And how many times it is occurring, that is 1 time. So we will multiply 5 1 time. And same is for the 7. 7 is occurring maximum number of times in 28 and that is 1 time. So we will multiply it 1 time. And this multiplication will give me the LCM. So that is 1260. Let's try to find the LCM by another method. The basic of this method is also same, that is prime factorization method. So here the algorithm of finding the LCM would be a little bit different than the previous one. So again the question remains the same, that we have to find the LCM of 20, 28 and 36. So here also we'll go with the prime factorization of 20, 28 and 36. Then let's see how to find the LCM. So find the common prime factors among all numbers. So if you see 2 is a common factor among all numbers. So this is 1. And another 2 is also, this is common among all the numbers. So if it is common among all the numbers, so we'll take these two as one, the second two as another one. Count rest of the prime factors as many times it is occurring in the different number. So if we see 3, how many times it is occurring? 2 times. Let's see 7, how many times it is occurring? That is 1 time. And then the 5 is occurring 1 time. Multiply all factors as many times it has been counted. So we will multiply this 2 1 time, this 2 again 1 time, this 3 2 times, this 7 1 time, this 5 1 time. So the LCM will come as 1260. So we'll try to find the LCM by another method. The basic of this method is also same as the previous methods, that is by the prime factorization. So what is different here? So different is that instead of getting factor individually, here all are divided at once. So division start with the least prime number which can divide at least one number. So let's see how it is being done. So here we have to find the LCM of 20, 25 and 30. So we will start with the least prime number, that is 2, and we know that 2 can divide at least 20 and 30. So after division what we will get? We will get 10 for 20 and 15 for 30. 25 we can't divide, so we'll keep as it is. Then again the whatever the quotient comes, that we'll try to divide with 2. So here we can see 10 can be divided and we will get 5. The rest of two things, right, 25 and 15 we can't divide, so we'll keep as it is. Right now we have 5, 25 and 15. We can't divide it by 2, so we'll have to move to the higher prime number, that is 3. So we know that by 3 we can divide 15. So we will divide it and we will get the quotient as 5 here, and the rest of the number we can keep as it is. Here the 5, 25 and 5 can't be divided by 2 or 3. So we'll have to move to the higher prime number, that is 5. So 5 will be able to divide all these three numbers. So we'll get 1, 5 and 1. Similarly, we'll again divide by 5 to get 1, 1, 1. So here the LCM of 20, 25 and 30 would be multiplying all the numbers, that is 2, 2, then 3 here, this 5 again, this 5. So what will get the answer here? So 4 into 3, 12, 5, 65, 300. So 300 would be the LCM of 20, 25 and 30. So whatever we have read till now, there are some observation. So what is the first observation? HCM of given numbers is either equal or less than the smallest number. LCM of the given number is either equal or greater than the largest number. So remember these things. Now let's try to do some question. So find the LCM and HCF of 20, 25 and 30. So we have already talked of many methods. So you use any of the methods and try to find the answer. So pause the video for some time and try to solve this question. The answer is there in the next slide. You can match the answer after you are done. So here is the answer. So this question has been solved by the prime factorization method, and the HCF is coming as 5 and LCM is coming as 300. So this is what I wanted to talk in this video. Thanks for watching this video.